Today we'll be discussing our medical discoveries to do with lasers. Evolution of lasers. In 1917, Einstein established the foundations of the laser. He proposed the theory that electrons can be stimulated to higher energy states, and when they go back to the ground state, release radiation in the form of light. In 1954, Towns came up with the maser, which he later renamed lasers. Towns wanted to use a laser light as a precision tool for his research on molecules. He was able to achieve this by shining a high-powered flash lamp on a ruby rod with silver-coated surfaces. In 1960, Theodore H. Maiman creates the first ever laser. He developed the first ever laser that was made out of ruby, which had a high chromium content and absorbs green and blue light, while emitting red light. By flashing white light on the cylinder of ruby, Maiman energized the electrons in the chromium. This emitted a very strong red light in the form of a laser. So, what are lasers? A laser is a device that emits light through a process of optical amplification that is based on the stimulated emission of electromagnetic radiation. We can only see visible light on the light spectrum. Other rays of light are invisible to the naked eye. A laser beam is a device that produces an intense beam of light of a single wavelength or color. The light waves in a single beam are coherent, which means the waves vibrate in the same direction at the same time. As a result, a laser beam can transfer a great deal of energy.
1 represents the power supply. 2 is the energy being pumped into the ruby crystal. 3 represents the absorption level when electrons jump to a higher energy level. After a few milliseconds, the electrons return to their original energy level, ground state, by giving off a photon of light. This is called spontaneous emission. 4 represents the photons that atoms give off zoom up and down inside the ruby crystal traveling at the speed of light. 5 represents one of these photons stimulating an already excited atom. When this happens, the excited atom gives off a photon and we get our original photon back as well. This is called stimulated emission. Now 1 photon of light has produced 2, so the light has been amplified. In other words, light amplification has been caused by a stimulated emission of radiation. 6 is a mirror at one end of the laser tube, keeps the photons bouncing back and forth inside the crystal. 7 is a partial mirror at the other end of the tube, bounces some photons back into the crystals but lets some escape. 8 is the escaping photons form a very concentrated beam of powerful laser light. What do we use lasers for? Welding and cutting wood? Communication?
We use lasers to receive and send data like videos and other information. This can be 10 to 100 times faster than a radio.
Laser printing.
Laser printers use beams that scan back and forth across a drum inside the printer, creating a pattern of static electricity. The static electricity attracts powdered ink, and a fuser unit bonds the ink and paper together.
CDs and optical discs.
A disc is burned with a laser that carves bumps, called pits, into its surface.
And barcode scanners. Medical uses of lasers. With high-powered lasers, we can undergo a procedure called laser therapy. Laser therapy uses a strong beam of light that can cut, burn, or destroy tissue. Laser eye surgery. Our product, laser eye surgery, can cut underneath the corneal flap to reshape the cornea without the need of stitches or bandages. This can help improve vision, nearsightedness, and ageism.
Would you like to try our new invention, laser eye surgery, to help with your vision?
Whoa! Oh my god, you help so much!
Our other product is tattoo removal, which uses a laser that pulses a beam of light which penetrates the skin and the tattoo ink. This will cause the tattoo ink to heat up and shatter into tiny particles. This activates the immune system to target the tiny ink particles and move them away from the tattoo location, which lightens the appearance of the tattoo.
So I heard you wanted to get laser tattoo removal. Is that so?
Yeah,
Well, why didn't you show the camera your tattoo?
I'm kind of ashamed of it. Everyone keeps saying it's a bad tattoo.
We're gonna show you how we're gonna remove it. Right now, I have this tattoo laser remover right here, and we're gonna bring this up to the camera. Come bring it up to your arm. You guys see this? Ready? I'm gonna start up here. Be very careful. All right. We're gonna remove it. Wow, it's already disappearing. Wow, would you look at that?
Results!
Wow.
Positive and negative impacts that lasers can have. The positive impact that lasers can have is the medical use of lasers, which we've introduced, and industrial uses to cut through metals and other hard to cut through elements. Negative impacts of lasers is that they can cause blindness if they're targeted at eyes. Another impact in the future is if our technology keeps advancing, they will be able to use lasers and more. This is our bibliography. Thank you for listening to our amazing product.
I hope you buy it because it's a very advanced technology.
We also just trying to make money, but that's